Hello and welcome to Sunoco's Ferry Rotational Molding Machine. Here at Sunoco we utilize 3 of these types of machines. This one is the largest, the Ferry Model 330. It has the most oven capacity and is able to run molds with a maximum diameter of 3.3 meters. The plant also has 2 smaller models, both are Ferry Model 220s, capable of molds up to 2.2 meters in diameter. These machines typically run with a 2-man crew, a senior roto operator and a second roto operator. Due to the larger nature of this particular machine and the resultant larger parts, the 330 also utilizes a prep man to assist in the transition of the molded part from the roto machine to the foaming operation. The basic principle of rotational molding is taking granulated medium density polyethylene of a specific color and weighing it into a specific charge weight, loading the powder into a hollow mold and then cooking it for a specific amount of time. The charges are weighed up in the order they will be used in the molds that are mounted on the machine's rotating arms. A simple and yet important step that will be performed every time a finished part is pulled from its mold. These pre-measured powder charges are staged and then loaded into a hollow cavity, mild steel or aluminum mold. Each individual mold is loaded with a very specific shot weight of plastic and the part is made to the color of the customer's order. Although the molds are loaded in slightly different fashions, the general procedure is almost identical for every mold. One operator will charge the mold while the other makes the necessary preparations to the lid of the mold, such as replacing the venting material and installing any molded-in components like the weld nuts that are used to pull the finished part from the mold. Special mold release will be applied at this time as well to prevent molded parts from sticking to the mold itself. When the mold is fully prepped, both operators will realign the 2 halves of the mold as it is lowered by the crane. When the 2 halves are mated, they will disconnect the crane's hooks and then clamp or bolt the mold back together, sealing it up so that it is ready to be sent in the oven to be cooked. The whole process so far is fairly simple and straightforward. The operator's biggest concerns during these stages of mold prep and filling are the accuracy of the shot weight, using the correct color of plastic, and making sure the mold is properly reassembled and closed. The shot weight, which is directly responsible for the finished weight of the part, is very important to ensure proper wall thickness and part-to-part consistency. If it is off by even a small amount, the wall thickness of the finished part can be compromised, resulting in a part that is either too thick or too thin, and in turn not up to quality standards. Accuracy and attention to detail is vital at this stage, as it affects not only the rotational molding machine, but all the other processes to follow. Once the mold is properly charged and closed, it is sent to the pre-oven station where it will await the automated cooking cycle. The operator will rotate the mold as it travels to ensure that it is properly closed and sealed. Utilizing the control podium, the operator will start the oven cycle. The doors will automatically open and the mold will enter a 600-degree blast furnace where it will rotate on 2 axes for a prescribed amount of time. Each mold is different and requires a different cycle depending on its size, shot weight, and shape. Some even require different cook temperatures and rotations. The powder will stick to the mold walls as it begins to heat up, eventually turning into a solid melted layer of plastic on all the walls of the mold. The melted plastic will continue to cook for a while, allowing all the trapped air bubbles to come to the surface, and for the molecules of the plastic to properly link together. When the cook cycle is complete, the doors will open automatically and the mold will exit into the pre-cool station. Here it will continue to rotate for 5 to 10 minutes as the mold begins to cool and the melted plastic begins to solidify. No fans or water are used during this station to prevent shocking the plastic. Cooling too rapidly during this stage can cause excessive shrinking, which can warp a part, rendering them unusable. The station also acts as a holding place for the molds, allowing them to cool naturally when there are other parts still in the final cooling station. The mold continually spins on the two axes of rotation in this station, ensuring that the melted plastic retains its uniform thickness as the part begins the cooling process. The mold will then move into the cooling station, where it will undergo a series of water jets, spraying a fine mist of water, followed by large fan air coolers moving large amounts of air across the surface of the mold. Typically the cycle is 1 minute of water mist, followed by 4 to 5 minutes of fans. The water mist rapidly cools the metal mold, and the steam created will be pulled up through the upper vent fan. The cooling fans will then dry the mold, making the next water cycle more effective. This will repeat 3 times, and then we'll finish with the cooling fans completely drying the mold. Rapid cooling during this stage creates a stronger plastic by helping to ensure the polymer chains crosslink. It also helps to speed up the overall cycle time of the machine. This cooling cycle is important for the operator to control because it also directly affects the finished size of the part. A part that is pulled from the mold too hot will shrink too much and create a part that is too small. A part that is pulled too cold will not shrink, resulting in a part that is too big. A typical cooling cycle is anywhere from 15 to 30 minutes. Once the part is cooled to around 180 degrees, the ideal temperature, it is ready to come out of the cooling station and to be demolded. As the part enters the demolding station, the operators will allow the mold to stop under the overhead crane and then begin to loosen the clamps and bolts that keep the halves of the molds mated together. All of the bolts and clamps, except a few, are removed or undone. This is a safety precaution taken until the crane has been secured to the mold. They will also undo and remove any mold inserts that would prevent the part from pulling from the mold, such as handle pockets and kiss-offs. Once the mold is in the proper position and chained to the floor when needed, the operators will hook the crane to the mold's hook points. While they are doing this, they will double check to make sure all of the inserts have been removed and all of the bolts or clamps have been undone from the parting line of the mold. This is a very important step, for if any of the clamps, bolts, or inserts are missed, the crane can cause severe damage to not only the finished plastic part, but to the mold itself. The operators will begin to work the part free from the mold, taking special care to watch for any sticking areas. If too much pressure is applied, the part can stretch and be distorted. However, as the plastic cools, it shrinks and will typically come free with only a small amount of coaxing from the crane. This process can take anywhere from a few minutes to 15 or more. Temperatures of the mold at the time of pulling, mold release application to the mold after the part has been pulled, and a bit of intuition on the part of the operators are key ingredients at this stage. The skill and experience of the operators, along with strong teamwork, will make things run smoothly. The operators need to have the whole demolding process complete, and have the mold recharged and sent to the oven so that the demolding station is clear and ready for the next part before the next part's cooling cycle is complete. If it's not, the whole machine will be delayed and production numbers will be less than ideal. When the part is freed from the mold, it is taken to the foaming prep area and the whole process will start over again. The mold will be prepped, all inserts will be reinstalled, all the venting material will be replaced, and mold release will be applied as needed. The proper plastic charge is poured into the mold, and the mold will be sealed up, rotated to check for leaks, and then sent on its way to the oven to begin the whole process over again. Once again, teamwork makes this process run smoothly. Operators' actions complement each other and in turn make it easier for both of them. Each man is thinking one step ahead in the routine so that every action is completed in time for the next. In this fashion, the machine is not slowed down and will run as fast as the program cycles allow. Problems are minimized or precluded completely, and the shift runs smoothly. In a typical shift, depending on the mix of molds on the arms of the machine, each mold will go through 6 to 10 cycles or rounds. Each round average about 1 to 1.5 hours. So the operators will be pulling parts out of the molds as each individual arm comes around roughly every 15 to 20 minutes. This is the basic cycle of a rotational molding machine. Charge an empty mold with powdered plastic, seal the mold, and cook the part in a 600-degree oven. Cool the part in open air and then with water. Pull the part, reset and refill the mold, and repeat. A very simple process, and with the right training, some experience, and strong teamwork, it is not overly difficult to master. It's an easy job to take pride in as well. The parts that are created on our machines will go to help thousands of people and businesses all around the world. From dry ice industries to grocery chains to pharmaceutical companies, our containers deliver products all across the globe and have a large and positive impact on people's daily lives. You never know where you might find the Sunoco Durable Transporter container in use and improving cold chain supply routes all around the globe.